In mathematics, you will frequently find yourself in situations in which binomials need to be multiplied. This tutorial will show you how it's done. This is an example of a binomial. Notice that it is the sum of two different monomials. In this case, it is the sum of 2x and 1. Here's another binomial, x plus 3. Let's multiply them. In other words, let's find the product. You're probably used to seeing multiplication written using the familiar multiplication sign. In this case, it's not needed because when two expressions are enclosed in parentheses and placed next to each other as shown, it's assumed they are being multiplied. To do the multiplication, we will use the distributive property. That is, we will rewrite the expression showing that 2x gets multiplied by both x and 3, and that 1 also gets multiplied by x and 3. Now we'll show the result. Notice that two of the terms can be combined. Let's do that and write the final answer. And there it is. People who see this done for the first time wonder why we made it so difficult. Why did we not multiply like terms? In other words, why didn't we just multiply 2x by x and 3 by 1 and leave it at that? The short answer is that doing so would violate the distributive property, and that's a no-no. It's wrong. Chances are, though, that the response does not help at all. Let's try a visual representation. You know you can show multiplication using area models. For example, you can easily demonstrate that 3 times 4 equals 12 using a rectangle that measures 3 units by 4 units. You can do this with binomials too. For example, we can use a block like this to represent x and a small square like this to represent 1. The large square block is x squared. We can represent a length of 2x plus 1 using 2 of the x blocks and 1 block. We can represent a width of x plus 3 using 1 of the x blocks and 3 of the 1 blocks. The product of the two, that is, the result of multiplying them, will look like this. Notice that in the result, there are 2 of the x squared blocks, 7 x blocks, and 5 1 blocks. We can therefore write the answer like this. Notice that it's the answer we found when we used the distributive property. If we had not done it correctly, that is, if we just multiplied the x terms and the unit terms, we would have left these parts out. So, let's recap. When we are multiplying binomials, we need to use the distributive property and multiply each term in the first binomial by each term in the second binomial. We can call this the FOIL method. It's an acronym for first, outside, inside, and last. If you bear this in mind and remember to combine like terms if needed, then you will always get it right.